Hi everyone, welcome back. Now we are going to see about the speed control of DC shunt motor. So speed control. A single motor can be used for different speed for different work. Okay, so just for an example, uh, for each and every application, for example, you can take a rice mill. So for the rising of for grinding oil, for making for each and every application, we have to buy different motor for different application for different speed. So we should avoid these kind of issues so that and with the help of a single machine we can able to attain at variable speed, different speed for different work for different application. So that is the main motto of speed control, so that it will be very flexible. The DC motors are very flexible to adjust the speed. A certain motor it can be operate for 1000 rpm, 1200 rpm, 1400 rpm, 1600 rpm. So based on our requirement we can able to vary the speed. Okay, so the smooth speed control is possible in our DC shunt motor. So the speed equation, the speed is directly proportional to V minus IA RA. It is nothing but a back EMF, and the speed is inversely proportional to flux. Okay. So there are two types. One is nothing but an armature control method. Another one is nothing but field control method. The armature control method is also known as voltage control method. Field control method is also known as flux control method. Okay. So the first one, armature control method. So in the armature control method, okay, so the armature should be controlled. So the armature should be connected with controlled resistance. The armature is connected with variable resistance. Okay, so here now you can imagine at initially the rheostat is in maximum position. At initially the rheostat is in maximum position. Okay. Now the current through the armature resistance is very low. The current through the armature resistance is very low. Okay, once if you are trying to increase the armature resistance, or it may be vice versa. Okay, so it is a simple logic. The current which is supplied to the armature is gets adjustable. So that the voltage is also an adjustable. The voltage across the armature is also an adjustable. Okay, so once the voltage is also adjustable, the current which is applied to the also a variable one, the speed is gets changeable. The speed is gets changeable. Okay, so here in the speed control method, here an armature resistance is very high. If you are decreasing the armature resistance, the current which is applied to the armature gets increases, the speed is also gets increases. The speed is also gets increases. Okay, one. So here the field is remain same. If the field is remain same, only thing we have to adjust the armature. Only thing we have to adjust, we have to change the armature alone. Okay. So here the resistance is nothing but a variable resistance. It is connected in series with the armature circuit. So according to the speed equation, the speed is directly proportional to V minus IA RA, because in addition to the armature resistance, we are adding the additional resistance. If the resistance is very high, initially resistance is very high, so the supply voltage minus IA armature drop is very low. So therefore the back EMF is very low. So back EMF is very low divided by some amount of flux. The flux is also always constant. So the back EMF is very low. The speed is also very low. So if you are decreasing the resistance, the current will be gets increases. So that the back EMF is also increases. So this motor speed also gets changeable. Okay. And the advantage, simple method of speed control. And here the input power is not changed. Output power becomes less for low speed, more power is wasted, so it is highly inefficient. This is an assessment. Which of the following assumption is true for armature controlled DC motor? So put your answer in the comment section. And this is nothing but field control method. So here The armature is directly connected with the power supply and the field is connected with a variable resistance. Okay, at initially the resistance is in minimum position. Once if you are trying to increase the resistance, resistance, okay, so here the supply voltage is back EMF is constant. Only thing, the flux. So first thing, the flux is very high, so the speed is very low. Once if you are trying to increase the resistance, the current through the field gets decreases, so the speed is enormously increases. So this is the characteristics between the speed and torque. Okay, so these are the advantages. It is a conventional and easy method. Little power is wasted as heat. Speed is independent of load. And the disadvantage, only speeds higher than the rated speed can be obtained. Okay, so this is an assessment. If the speed of the DC shunt motor is increased, the back EMF of the motor will increase, decrease, remain same, or become zero. So put your answer in the comment section, and these are the few references. Thank you.